Hello everyone, my name is Charles. I'm a 8th semester engineering student in Indonesia. So today guys, I'm gonna give a quick tutorial on how to design an embankment in Plaxis2D. So first of all, you're gonna see the screen. What you're gonna do is go to the model section and gonna set the area of your work. So for this, I'm gonna just do 20 meters, and the embankment would be around 4 meters. So I'm gonna just do uh, 6 meters, and for the ground level, about 10. Okay, so now we've got a grid where we're gonna do the modeling. So first of all, you could model using Borlogs, and you could just click on the coordinate you're gonna put the boreholes, and you could just set it from here. But for this event, I'm gonna just manually design the geometry. So first of all, you're gonna create a line. This is to make the polygon more easily to be drawn. So I'm going to just randomly create a line on 20 meters. For the depth, I'm going to do 3 meters for the first layer. So what you're going to do is you're going to left click and drag the line, and to finish you're going to click the right mouse button. And now we're going to design the embankment. I'm going to do 2 horizontal, 1 vertical slope around. Probably I'm gonna just do 2 meters for the slope. So 2 meters, that's 4 horizontal and 2 vertical. Okay, so now we've got the basic geometry. Now we're gonna make a polygon. So you go to this option and click create soil polygon. So you're gonna follow the geometric line that you've created. So when you're finished, you're gonna right click. For this example, for the embankment, I'm gonna just do it in one go, so there's no stage construction. And you're gonna click the geometry. So now we've got a basic mesh polygon for the mesh, which hasn't been assigned with the material. So what you're going to do is you're going to go back to the soil section and show materials. And for this, you're going to set the soil interface. So you're going to click new. For this, I'm going to just simplify using just probably one material for the footing of the embankment. So for this material, I'm going to use a more column with the parameters I'm going to just randomly assign. So 17, I'm going to do 19. The models, I'm going to just do 10,000 for the Poisson 0.3. See, this is for this event, I'm going to do it using Android A. So we're going to use the effective parameters. So C effective is around 0.1 of the undrained cohesion. So I'm gonna just put 10. So that's around no, not 10. I'm gonna do around probably 5 5 or 6. And for the fee, I'm gonna do 28. Now this is, you're gonna just leave it on default. For the ground parameters, I'm gonna, because I don't have a data, so I'm gonna just use a normal parameters from the dataset, just grain this size distribution. So it's gonna automatically select the horizontal permeability and the vertical permeability. For the interface, I'm just gonna leave it there. Okay. Now we've got the base soil material. Now we're gonna do the embankment. So for this, I'm gonna still use undrained A. So what undrained A does is it gives a result for the pore pressure. So it takes account the pore pressure measurement of the analysis. So now I'm gonna do basically the same. So 17, 19. And for the parameters, I'm gonna do 10,000 with the same Poisson ratio. And for the cohesion, normally an embankment is around 10, and the internal friction angle is around 26. And for the permeability, I'm going to use course, yes. For this example, I'm going to change the base material to be clay, so we'll have a consolidation effect and pore pressure increase. So I'm going to do fine. So as you can see here, the permeability gets a lot smaller than before. Okay, now what you can do is you can drag the materials one by one, or you could press the polygon and select it manually with this. Like, okay, after it's all set, it should be colored, not gray like before. After this, you're gonna you could, in Plaxis, you could create a line load or geometry. For example, if you have infiltration, you could do the infiltration. But for this, I'm just gonna do geogrid, one geogrid in the 1 meter height. For the geogrid, wait, we haven't signed the material. So I'm gonna just go geo1 with the E8. So what is the modulus and the area? So what you're gonna do is go to calculator. So for example, I have a geogrid with the axial strength of 100 kilonewtons per meter. So I'm gonna go 100 divided by the area of the cross section. So for a geogrid, it is around. So we're gonna define it as per meter. So for the thickness is around 5 millimeters. So 0.005. So we should get around 20,000. So we're gonna copy, and okay. For the geogrid, you need to do an interface. So you select the interface and create and follow the geogrid. You could do this manually from the selection explorer, but I rather choose the geometry side. After that, let's model a load. Where's the load? So yeah, here. There's a line load. So I'm gonna make, for example, a line load with I'm gonna do 5 kilonewtons per meter. Okay, now after you've done all this, you could go to mesh and generate mesh. So the benefit of using Plaxis is it's easy to use because you could just automatically create a mesh. So I'm gonna make it very fine. After it's done, you're gonna take a look at the mesh. So this is the mesh that has been created. As you can see here, there's the geogrid and the embankment mesh and all the other mesh with the boundary conditions all set. After this, you're gonna do flow conditions, but for this example, I'm gonna just create a new water level. It should automatically assign to the 0-meter elevation depth. So I'm gonna do it just below. Some mistake. Wait a minute. So I'm gonna just assign a new water line. Okay. Now we're gonna go to stage construction. Okay, let's just leave it there. So now we're gonna create an initial phase. So this is gonna calculate the initial stresses and all the pressures, the hydrostatic pressure. So yes, this. So now you're gonna activate the base soil. So for this, it's gonna calculate the initial stress and the pore pressure from the groundwater level height. So now let's calculate first. Okay, it's done. First of all, you guys need to look at uh, the stresses. So we're gonna go to total stress first. So as you can see here, for this example, this is the initial stress. It's around 120 or like 114. So for this, you're gonna just check. So for example, this is from below the water. So we're gonna do, that was 19, I think. 19 times 9. No, 17. It's 9. Wait a minute. It's 6 meters, sorry. So for example, that's Andrin's unit weight. So 19 times 6 meters. It should get around 114. So the initial stress is okay. So let's close. And for this, I'm going to do a consolidation analysis. So for the deformation. Now we're gonna activate the construction stage. Sorry now. So we're gonna activate the embankment. For this, I'm gonna say fill phase. So the time interval, this is for a 2 meters embankment. So I'm gonna do 14 days, so 1 week. Sorry. For around 10 days. So we're gonna do the plastic calculation type, and the loading type is straight construction. Okay, so let's calculate. Okay, so let's check it again for the results. Calculations. Okay, so this is the effects on the embankment after the fill. So as you can see here, the stresses automatically has increased from 114 to 145. So, okay, for the deformation, here, this is the case. So the max deformation is 8 to the power of minus 10.3. Okay. So now, we're gonna do the safety calculation. So what you're gonna do is you're gonna change the calculation type to safety. For this, you're not gonna change anything. And let's calculate. Okay, let's continue. So the problem with the safety is it's gonna take a long time. So what you're gonna do is you could actually change the maximum steps that the safety calculation is gonna calculate. But for this example, we've got the safety factor of 1.952 without the load or the yogurt, so it should be safe. So what we're gonna do is we're gonna put a load and see what happens to the safety factor. So what you're gonna do is you're gonna click the fill phase and then you're gonna add a phase. So what you're gonna do is it's gonna split up the phases and you could have a new phase down here. So this is the loading type. I'm just gonna still do plastic. The loading type I'm gonna do 1 day with the, yes, just like this, and then I'm gonna activate the load, so it should be activated now, and I'm gonna add a safety phase again. Safety, change it to safety, and for this, just as I said, if it's taking too long, you could actually change the maximum steps. So I'm gonna change it to just around 20 to make it fast. and others you could experiment yourself. Let's calculate. As you can see here, the safety factor just dropped. So as you can see here, it dropped from 1.9 to 1.6. So with the load, it's going to drop the safety. Now let's experiment using the GeoGrid. So what you're going to do is you're going to select the face you want to activate the GeoGrid and select the toggle activation. Then what you're going to do is you're going to press the GeoGrid and it should automatically select the interface if it is on the same line. So when the interface is active, you could now try again. As you can see here, the grid makes the safety factor increase a lot, and now it's around 2.15, so there's a increase. So that is it. But for example, you wanna increase the load, so you're gonna go back to the structure and press the select button, and you're gonna press the load, and you could change anything. So for this, I'm gonna increase it to 10 kilonewtons per meter, and for this, I'm gonna create a pseudostatic pressure, not pressure, load, and let's see what happens. Hmm. Okay, so for this example, I'm gonna go to face and I'm gonna add a pseudostatic load. So what you're gonna do is you're gonna go to model condition in the model explorer, and you're gonna plus expand the options. Then you could go to pseudostatic and you could add an acceleration. So I'm gonna add 0.14. Either first of all, you're gonna have to experiment with the positive or the negative acceleration, because sometimes the resulting pseudostatic load could actually increase the safety factor. So now you're gonna experience. Let's load and calculate again. Oh, sorry. So I haven't actually activated the pseudostatic. That's why the safety factor is still the same. So what you're gonna do is you're gonna press this box here. So you're gonna activate the pseudostatic. What's this? Oh, sorry. So what you're gonna do? So you couldn't create a pseudostatic pressure from the safety phase. So you're gonna have to do it in the loading type. So let's select it and let's run again. So as you can see here, from the, 2.15 to now the safety is 1.432. So for the Indonesian standards, for the static condition, the minimal safety factor is 1.5, but for the pseudostatic condition, you could go down to 1.1. So the embankment still is okay from the law perspective. Alright guys, so that's it for the tutorial. Thank you so much for watching. Cheers.